Hi everybody, welcome to this new webinar from Variscite. I am Pierluigi Passaro and I am part of the software R&D team. Today I will go with you through the description of what is the wxWidgets framework, and we will go through the steps for the configuration and the use of this framework. Okay, let's go, starting with a brief introduction about Variscite. Variscite is the first ARM-based vendor for SOM. We are selling currently over 1 million units per year. We are on the market since 60 years ago, and currently we have something like 5,000 customers worldwide. We have a very diversified portfolio of SOMs, and we are the platinum partner of NXP, actually the only SOM vendor that is a platinum partner of NXP. We have in-house production facilities, and we cooperate with several partners. And also we have a medical certification for whatever solution you may want to need. The aim, the goal of providing to you SOMs is to provide a faster time to market, reduce R&D costs, provide scalable and upgradable solutions. All of our hardware is production ready, tested and used by over hundreds of customers. We provide full customer support to the, we provide free support to the customer through the customer portal, and we have GitHub pages, Wiki, and also the in-house production for stable availability and list time. Also, we do provide long-term longevity compatible with what NXP provides to us. Let me spend a few words about our pin-to-pin families. We have two main families, the VAR-SOM family and the Dart family. The VAR-SOM is scalable starting from the MX8M Plus, the MX8, down to the 6U, to the MX6, the Solo, and the 6UL. For the Dart family, we do provide support for IMX8M Plus, IMX8M, and the IMX8M-MINI. Now let's start with an introduction about the wxWidgets. Nowadays, many customers require to have an attractive and functional GUI, and in order to provide this kind of application, usually the developer requires a functional leader that provides support for writing and debug the code. Also, it's very useful to have a graphical editor to create the graphical interface and its front end. Use of series of libraries and APIs that allow to control and manage also the hardware. In this webinar, we will show how to use wxWidgets to create a graphical application for embedded systems, how to set up and use IDE like code blocks, to write code, to design the user interface, compile and debug your application. Let's start talking about what is the wxWidgets. wxWidgets is a library to create a cross-platform application. Actually, you can build the application and then cross-compile it for Windows, macOS, and Linux using a single code. It's based on modern C, C++ languages. It also provides several bindings for Python, Perl, whatever you prefer. It includes a rich text of APIs and several pages for documentation and a lot of classes and functions. Here, just a reference page, just to show the big amount of classes that are available for this framework. We will go just through a subset of this, but as you can see, there are a lot of possible classes to be used. What is wxWidgets? Basically, when you approach wxWidgets, you will see that there is quite a wide documentation, over 170 and 700 pages. It's completely free, open source, and very mature. It's on the market since 15 years ago. And also there is a very active community, and provide a lot of reference examples. Let's try to understand which are the development tools available. How we can develop with wxWidgets application. Basically, we will use an IDE that is code blocks. Code blocks include a simple and dedicated GUI editor for wxWidget that is called wxSmith. With this editor, you can design your application using the mouse, compile, and easily debug the application. You can develop your application for whatever platform you need. And in this specific webinar, we will analyze the context with wxWidgets 3.1. We will use a NOS platform based on Ubuntu 20.04. And as a target, we will use the Dart MX8M-MINI or VAR-SOM-MX8M-MINI according to your needs. First of all, we need to start configuring the Variscite SDK. We need to set up the environment, and we need to install on the PC wxWidgets. wxWidgets is available in terms of Debian packages from dedicated repositories. Here we do provide the basic instructions that you may run to install wxWidgets on your PC using the Debian packages. But if you prefer, you can build it from scratch using the standard installation instruction that you may find in the wxWidget documentation. Once done, we need to install the code block IDE. And simply on any Ubuntu terminal, you can run this instruction, and you will download the code blocks 2003. Now let's start creating a sample application for your PC. Once you install the code blocks, you can create a new application, select a wxWidgets project, select the graphical editor, so wxSmith in this case, and also select the version of wxWidgets. In this case, we are talking about the version 3.1. Once you do these steps, you will reach a page where you will see a graphical form where you will be able to drag and drop objects, buttons, labels, whatever. Once you are fine with the design, you press run, and your application will start running. Whenever you move an object to the drawing section, automatically the code will be generated and run according to your needs. Once we had everything set up for the PC, we can start moving to the embedded target. How can we do this? We need a set of libraries compiled and installed on the target file system, a complete tool chain to cross-compile the application on our target. We need to deploy the application into the target and start the debugging tool to fix and maintain our source code. Let's create the application starting from the reference example for the VAR-SOM-MX8M-MINI. The same applies also for the Dart. It's the same. What we do provide, basically, we started from wxWidgets 3.1 for Yocto. We introduced some patches because we were cooperating with the wxWidgets community to basically remove the X11 dependency. As you may know, there is a kind of change process, ongoing change process in the embedded community that is moving all the old X11 platform to Wayland. And this is slowly happening also in the PC world, at least for Linux. And this was originated by some constraints that were embedded in the X11 architecture. Nowadays, Wayland is the most reasonable follower for X11. there are several ongoing projects also for Debian and Ubuntu to move even the PCs to Wayland. For the time being, we were working with the wxWidgets community to remove the X11 dependencies from wxWidgets. Nowadays, we still have to push these changes to the community, but we do provide here a reference image that you can simply download, the toolchain, the patch that you may want to apply in order to get this working in your Yocto Downfield build, but also a quick README to understand which are the steps in order to proceed further. The main step here is correctly configure code blocks. We do provide a general wiki page where we configure a general toolchain. In these pages, we will go through the steps because the custom toolchain that we are using today will require additional settings to support also wxWidgets, not only the standard C libraries. So you can install the toolchain. You can create an appropriate compiler settings in code blocks, setting the compiler path, the linker path, the compiler flex, and the debugger configuration. We will create an application, and we will provide a dedicated template in order to run our target application. First of all, let's start installing the cross toolchain on the PC. This is the toolchain that you can download from the previous page. Once you download it, just ensure that it's an executable, because maybe during the download you may lose the executable flag, and just run it. Okay, the script will install the application in a default path, and you can check that everything is actually set up running this command that will provide details about the wxWidgets configuration. wxWidgets for Linux at least is based on GTK3, and the GTK3 for Linux currently is based on Wayland. This is the full path of dependencies. Okay, now we need to configure, first of all, the debugger, and we will create an additional debugger starting from the default one. We create a kind of copy, and then we will set the right path. That is the one for our own toolchain. Once we set the debugger, we need to set also the compiler. So we will make a copy of the standard compiler, and we will start customizing it. We will enter our own name. We will set the right path for the executables, and we will set the dedicated set of flags that are required for wxWidgets. These flags are partially similar to those that you may see in the wiki page, mainly because we are using a dedicated toolchain here. Okay, once we set up the cross compiler, we also need to add the linker options to find all the expected libraries. And this is the first part. We completely set up the environment for the toolchain and the debugger. Now we need to start to automate all the steps. First of all, we need to create some helper script just to avoid to run manually all the instructions that we may need. Code blocks by default allow to create some pre and post build script, some pre and post debugging script. And here we go through the process to create those scripts. First of all, we create a kind of configuration file that will include the basic configuration. I mean, the folder on the target that will host the application binary, the target IP, the port used to communicate with the debugger. And this is there is also here an additional SSH option that is used to bypass the key verification and speed up the connections. Okay, this is just a configuration file. Actually, it's not a script, but it will be used to create the deploy script that basically is in charge to copy the file. It's mainly it's an SCP, and it will prevent the auth verification and will copy the file to the target. The second script is the one that is charged to start the debugger. So we kill the previous instance of the debugger and then we run it again on the new application. Once this is done, we are almost up and running. We can start creating our own application. We selected the wxWidgets project. We select the wxMIT editor. And we need to set the specific properties for the project. So we need to alter the compiler flags to use only the target options, just to avoid contamination with the host. The same will be done with the linker. We need to avoid contamination with the host also for the linker. And we are going to activate the script that will be in charge to deploy the binaries. So basically, after we started the compilation and we completed the compilation, this script will be in charge to transfer the file from the host PC to the target. The target output file is an embedded variable within code blocks that will be used to point to the binary that we need to transfer. Something similar will be required for the debug. We need to set the configuration for the debugger, so the IP and the port, and then run the script settings in the running a dedicated script before starting the connection of the GDB debugger. Once we are done, we can click OK, and we will see our form where we can do, as I said, whatever graphic we need. We can use button, label, create our own graphic. The software will be compiled and uploaded to the target. At this point, we can start debugging. But let's try to analyze how wxWidgets work. We will go through the general architecture of a wxWidgets application, beginning and then the application, how it works, how to show the main window, how to react to the user action, and how to draw to the screen. So let's start from the general architecture of a wxWidgets application. Every wxWidgets application defines a class derived from the wxApp class. As a minimum requirement, this class must include an onInit function. This onInit function is in charge to create the form, and when the onInit function returns successfully, the event loop is started. So as you can see in the bottom right of the slide, this is the code that is automatically generated, and once it returns successfully, the event loop is started. Okay, basically when you run, when you use the graphical editor, all the GUI elements are created within the main application constructor. It's automatically generated by the wxMIT editor, but additional code can be manually added by the developer out of the region that is automatically generated. And you can identify this because of the standard C comments. The area between the comments is actually the one automatically generated. Outside of this area, you can put whatever you like and will be untouched by the graphical editor, I mean. This class basically provides the main window. In the class, you may see the declare event table that is a macro that enables the form events handler. So basically, here you will be able to connect action, the user action, to some dedicated function. The approach is the one that connects signals that are user events to dedicated application that you may implement. As we said previously, wxWidgets provide a set of standard widgets and control. You can create your own according to your need and according to your look and feel, whatever you like. And you will find the dedicated classes to manage fonts, colors, line drawing. And these classes are very useful to create your own brand new widgets. One of the main component of the wxWidgets graphics is the device context. This is a kind of object where you can draw things, and any drawing operation is performed referencing this class. You can create multiple device contexts within your application. They will be independent, but also they will have independent coordinates. So whenever you create a graphical context, a device context, sorry, each graphical context will be addressed and will have its own coordinate system, but also its own clipping region. So if for error you draw something outside the device context, it will not affect the rest of the application. The device context can be provided in several ways. Here is a list. You can address the memory, the printers, the screen, whatever you like. This is just a list for your own use, but here we will just use the standard client DC. This is a sample with the paint DC. This is the function called onPaint, so the onPaint event. The device context can set the pen style, the brush style, get the size of the current area, do whatever you like, draw rectangle and so on. Let's have a brief view of the APIs, of the available APIs. This is just a summary, but there are much more. We will focus on specific API like the pen that will allow you to set a specific way of drawing lines. The brush that is used to fill area, and you will have the chance to set your own style or use something of pre-formatted, let's say. There will be preset font, but you will be able also to use two-part font, and the bitmap. This is just a general overview that will help you to provide to start setting up your application. Let's say that we will also provide you a graphical application, demo application in our GitHub repository, where you will find the example about these classes. So let's start with the question. As I said, the wxWidgets application can run with the same code also in Linux, like in macOS and Windows. The code will not change. We have a question here about how the code change between one system and the other. So you can develop your application in Windows and then port it to Linux. It's the same. Is this supported for VAR-SOM-MX8? Basically, there is support for whatever system can use a Wayland backend. So it doesn't matter if you're using the MX7, the MX8, the MX6. If you select the Wayland backend when you do the build, you can do whatever you like with wxWidgets. Is this support for AutoCAD? Currently not. The point is that the community side, this recipe is it's quite new. It's been introduced recently. And also, if you look at the community recipe, it's introducing a forced X11 dependency. So what we have here is something, let's say, preliminary that will be pushed to community as soon as possible. But I'm not expecting that the community will backport to TAD because TAD reached its end of life. Any integrated support for video? Yes, we worked with the wxWidgets community to introduce native GStreamer support. And there is full integration with the GStreamer acceleration. So you can play videos using the VPU if you have a SOM using the VPU. Have browser control. Yes, wxWidgets has, in the list of the APIs, has a sample browser that you can run. It's directly available in the list of sample, and actually you will be able to find it also in the demo image. You can just go through under OPT shares. If I'm not wrong, there is a dedicated folder with the example, and you can compile on the target because the demo image that we provide also contains the compiler, and you can run it. It's a demo browser basically. JavaScript support, not sure. I don't know, we need to check because the demo integration of the website part is done through WebKit GTK, and I don't know what WebKit provide in terms of JavaScript support. I would say yes, but we should check. Does support 3D asset? Let's say that there is not a specific integration with 3D, but being C code, you can integrate your C code calling native 3D APIs. So this should be reasonably possible. Any other question? Touchscreen support? Absolutely yes. We tested it with the standard evolution kit, and the touchscreen works out of the box. We did not test it. We have a question about cameras. We did not test specifically cameras because we didn't find a dedicated camera example. But basically, since the camera is managed usually through GStreamer, I would expect that it should work simply as part of the GStreamer support. Is it possible to configure the full screen window? Yes. In the example that you will find in our GitHub repository, you will see that there is a sample application, and in the developer area, I mean the part of the code that is not under direct control from the GUI editor, we placed a dedicated ifdef only for ARC64 platform that automatically set the window to full screen, also ignoring the status bar for Wayland. We have a question about GTK Wayland dependencies. So basically, wxWidgets is based for Linux on GTK libraries. GTK libraries nowadays are provided as part of the version 3 branch development, and the GTK can work using X11 or Wayland backend. The X11 in the modern platform is going, at least for the embedded world, is going to, let's say, disappear. It's not the right word, but let's say that Wayland is gaining against X11 because of the new architectural feature. And that's why we focused mainly on Wayland. We have a question about the Wayland full screen. Not sure if it's the same question I received before, but basically Wayland by default covered the whole area. You can set the feature to have a status bar, but you can disable it. But beyond whatever you set, wxWidgets has a dedicated function to ignore the toolbar area and write to the whole frame buffer, to the whole screen area. Beyond this, you can work also with Windows because Wayland does support Windows, multiple Windows, and according to your need. Of course, the slide will be available. The webinar will be available in our from our page in the training area of the website. So you will be able to reach the slide, the video, and whatever. And once you get to the slide, you will also have the link to the images that we use as images. You will find the recovery SD card, dedicated recovery SD card that will allow you to install the images on the target. Once again, this has been developed specifically for Dart MX8M-MINI and VAR-SOM-MX8M-MINI. The same should apply to whatever platform you prefer, but we tested specifically in these conditions. Okay, let me add that this is just the first part of the webinar. There will be a second part where we will talk about a dedicated application. Here we went through the standard framework capability. We will show you how to create a card dashboard. Someone from the previous webinar may remember something similar. We will go through something similar also for wxWidgets, and we will describe step by step what we did and how we achieved a similar result. Okay. So at this point, I will say thanks for following us in this new webinar. I hope you will join us for the next one. Thanks for joining. Bye-bye.